Hello, so today's lesson for geometry students is going to be about the properties of a parallelogram, section 5.1. So a little bit of this is definition based, so let's get started. So we've talked about what a quadrilateral is. A quadrilateral, remember the word quad means four, okay? So a quadrilateral is a four-sided polygon. Now remember, polygons have actual sides. So like a circle doesn't have sides, right? So a polygon has to have sides. And anytime we see quadrilateral, it's a polygon, and it has four sides. But this section, we're going to be talking about more specific quadrilaterals. One of my favorites is called the parallelogram. Parallelogram. And again, there's that word we've seen a lot this year, parallel. A parallelogram is a quadrilateral, so it's telling me it has four sides, a quadrilateral with both pairs of opposite sides parallel. Let me remind you that I can use that symbol to mean parallel. All right, so a parallelogram, like this picture I have right here, has both pairs of opposite sides. So these sides are opposite sides and they're parallel, but both pairs of them have to be parallel. So these have to be parallel as well, and that's a parallelogram. When we talk about a parallelogram, or we use a symbol for it, we're going to draw actually a little parallelogram, and we would say A, B, C, D. And so we're talking about parallelogram A, B, C, D. Now, if I were going to draw that, though, I've got to be really careful. I can start anywhere. For our class, I'd like us to start in the left corner with the first letter and go clockwise. So the B would have to go here, and the C here, and then the D here. Now, I could put the A here if I wanted to, but if I did, then A, B, C, D. Or if I put the A here, I could also go A, B, C, D. So you got to be really careful. So I decided that for our class, what we're going to do always is going to go start in the left corner and go clockwise. All right, so that's our parallelogram. It's really cool because the parallelogram has these cool properties. So I want you to pay really close attention, as you never know when I'm going to give you a pop quiz on the properties. All right, property one, first property. Opposite sides of a parallelogram are congruent. Opposite sides of a parallel are congruent, which you know means that they're equal. So if I'm given parallelogram ABCD and I'm told that AB is 2x plus 1 and DC equals 4x minus 19, the first thing that we should do is draw our parallelogram and label our sides. So we'd have A, B, C, D. And if opposite sides of a parallelogram are congruent, I'm going to mark opposite sides congruent. All right, this tells me that AB is 2x plus 1 and DC is 4x minus 19. If opposite sides of a parallelogram are congruent, then I can write an equation. So 2x plus 1 equals 4x minus 19. Now it's time to use that algebra. Solve for x. It's a linear equation because the highest exponent is a 1, which means we balance the equation. So we bring the 2x, we subtract it to both sides using the subtraction property. We add 19 to both sides. So we get 20 equals 2x, and so then x equals 10. All right, let's look at property number 2. The second property of a parallelogram. Remember, a parallelogram is a four-sided polygon, a quadrilateral with opposite sides parallel. Opposite angles of a parallelogram are, you guessed it, congruent. Okay, opposite angles are congruent. So in this case, I know that E is congruent to G and H is congruent to F. Opposite angles are congruent. All right, so if I want to solve for a variable, like in this case, solve for y, I can write an equation. 6y plus 4 equals 3y plus 7. Okay, it's a linear equation. Why? Because the highest exponent of the variable is a 1, so it's where we use our algebra, we balance our equation. And we subtract 3 to both sides, subtract 4 to both sides, and we get 3y equals 3, and then divide by 3. So y equals 1. Again, property number 2, opposite angles of a parallelogram are congruent. A couple more. The third property, one of my favorite properties. The third property basically says that diagonals of a parallelogram bisect each other. Bisect each other. Remember that bisect means cuts into 2 equal parts. Okay? All right, so here's a great example. In RSTU, parallelogram RSTU, draw the diagonals and mark the point of intersection X. Okay, so I'm going to do that. I'm going to draw RSTU. There's my parallelogram. And R, I'm going to start in the top left corner, clockwise, RSTU. I'm going to draw in my diagonals. These are the diagonals. The diagonals go across. Okay, and then I'm going to mark their point of intersection X. If the diagonals bisect each other, that means that when they cut each other, they make Rx and Xt equal. That's bisecting. And it makes Ux and Xs congruent as well, which means that X is actually the midpoint of both Us and Rt. All right, so in this particular example, it says that Rx is 6x plus 1, so I'm going to put 6x plus 1 here, and Xt is 4x plus 31. Well, if the diagonals bisect each other, and those are actually congruent, then I can write an equation using algebra. So 6x plus 1 equals 4x plus 31. Now, I look at it, it's a linear equation because the highest exponent's a 1, so I'm going to solve by balancing. Subtract 4, subtract 1, I'm going to get 2x equals 30, so then x equals 15. So that's an example using that third property, that the diagonals of a parallelogram bisect each other. Okay, last and fourth property, last one to learn. The fourth property says that consecutive angles of a parallelogram are supplementary. Well, let's look at that. If opposite sides of a parallelogram are parallel, well, that means that A and D are same side interior angles, so they would be supplementary. And A and D are consecutive angles. Well, that would also mean that A and B are supplementary because they're same side interior angles. A and B are consecutive angles. So that means that every consecutive pair of angles, A and B are equal 180, B and C equal 180, C and D equal 180, and A and D equal 180. And that's a really cool property of a parallelogram. Okay, so that's our fourth property. So now what I want you to do is I want you to answer the questions at the bottom of the page, but I want you to try and do it without looking. See if you've memorized them already, okay? The last thing I want to do is I want to go back to page 1. I want to talk about that quadrilateral, and I want to remind you that in a previous unit you learned that the four angles, the four interior angles of a quadrilateral are you can use the formula n minus 2 times 180, but we know that the four of them are going to add up to 360 degrees. The four interior angles of a quadrilateral add up to 360 degrees, and the four exterior angles of a quadrilateral also add up to 360 degrees. All right, guys, see you tomorrow. Have a great day.